Hello again. We're going to talk now about molecular mass and also the concept of the mole. All right, and the mole is the number of particles in what is known as the chemist's dozen. Now, obviously, molecules and atoms are very small, and there are a great number of them. So it doesn't do us any good to kind of talk about them in terms of dozens or even of grosses or thousands. We talk about them in terms of moles. And the mole represents 6.02 times 10 to the 23rd particles. All right, so this is a very, very large number, an extremely large number. This is 602 sextillion particles, all right? 6 followed by 23 zeros. All right, that is a very large number. And in reality, this is a very good number to use for us because it affords us as chemists the ability to use the same value on the periodic table for the mass of one atom of that element in terms of atomic mass units, but also then the 1 mole of that particular element in grams. And we'll see that as we do the problems. So in looking at page 184, number 77, the question is talking about how many grams of hydrogen peroxide, H2O2, exists in a different number of moles. A is 1 mole, B is a half a mole, C is 10 moles, and D is 0.678 moles. Well, first of all, in order to solve this problem, we need to determine the molar mass. Okay, and really, molar mass is just going to be the sum of all atomic masses. All right, in H2O2, we've got 2 H's, and we have 2 oxygens. Looking at the periodic table, H is 1.008 AMU, and oxygen is 16. All right, so if we do this math, this ends up becoming 32, 33, 34, 34.02 AMU. All right, so one single molecule of H2O2 hydrogen peroxide is 34.02 AMU. But as I said on the periodic table, if we want to go between a single atom or single molecule of a particular thing all the way up to a mole of things, we can interchange grams and moles, and this will be 34.02 grams per mole. All right, so if we're talking about one molecule of hydrogen peroxide, 34.02 AMU, atomic mass units. However, if we want to talk about a mole of them, it's 34.02. So if you have 1 mole, 34.02 grams. If you have 10 moles, 10 times 34.02 will give you 340.2 grams. Half a mole, half of 34.02. So if you have half a mole of hydrogen peroxide, you're going to have 17.01 grams. Let's look at D, and it's asking us about 0.678. All right, well, this is just a dimensional analysis problem, okay? If we multiply this by a fraction, okay, we need moles on the bottom. We need mass, so that means grams need to come out on top. So we're going to have grams here, grams per mole. So we're going to be multiplying by this particular molar mass, and that's really all we need to do there. All right, if we set it up correctly in this way, moles cancel. We're left with just grams. We take our calculator, 0.678 times 34.02. We end up with 23.1 change. There are 3 sig figs here. There are 4 sig figs here. So our answer needs 3 sig figs, and we round it to the 3 sig figs, 23.1 grams. So this is, as I said, just a version of a dimensional analysis problem, but it's using the concepts that you're learning right here. Now, how many particles would this be? Okay, if we had 0.678 moles, how many particles is that? Well, as we see, 1 mole is 6.02 times 10 to the 23rd particles. So, how about we do the math right here? 0.678 moles times 6.02 times 10 to the 23rd, and that's particles per mole. Moles end up canceling, and we're left with 4.08. 3 sig figs again, 4.08 times 10 to the 23rd particles.